let's find the domain of a few more functions. And so building upon the last video, in the last one, we were when we're trying to find the domain, we're trying to figure out what are the valid input values that are allowed in this particular calculation. So in 2x plus 3, it was anything, and so that's kind of where we start with the domain for a lot of mathematical functions. But certain formulas and certain functions have values which do not work or are not allowed. It's kind of like what I was saying up here, is that certain numbers might be invalid because reasons. With the World Series, it's just because only integers made sense. But with mathematical functions, it might be due to the calculations at hand producing values that do not work. So in this example, specifically with division, there is a problem area with dividing by certain numbers. And if I ask you right now, what number are you not allowed to divide by, there's only one answer, which is, as you'd probably say, 0. And there's actually a really interesting reason why you can't divide by 0. And if you ask Siri, she says something really funny, or at least she used to. But anyways, I'll talk, if you're curious, we can talk about that in office hours or something. But basically, sometimes there's numbers that do not work, and it's because within this calculation we have 1 divided by x plus 2. And if I'm examining the denominator of this fraction, there is it is possible, depending on what x would be, for this to create 0 in the bottom. And so notice in this case, it'd be when x is equal to -2, right? Because if I plug in -2 for x here, I would get 1 divided by -2 plus 2, which is 1 divided by 0. And that would introduce that problem. And dividing by 0 is an undefined operation in math because it just doesn't make sense. And that's one of the ways that with functions that involve division, if you're wondering, how do I find the domain? Well, what you want to first do is figure out where is the denominator 0. So this can be done by writing a little mini equation, x plus 2, setting it equal to 0. What's probably more proper to do is write that x plus 2 cannot equal 0 because it's not allowed within the domain. And you can write it either way, but this is a little bit more proper. And then if I subtract 2 from both sides, what I would have is that x cannot equal 2. And this is a very typical way we describe what values are not within the domain. And so again, if we were trying to now express the domain, the implication is that, well, any other number works, right? So 1 is fine, -1 is fine, 3 is fine. Basically, anything other than this is totally cool. Again, unless there's any other problems. And that's kind of the way I like to think about it, is if I'm trying to find the domain, I'm looking for what are the problem areas in this. And that's part of understanding a mathematical function, is knowing its domain is a really important part of it, because it's like knowing what values are valid and what are not. So if you were just trying to write this in words, you could say domain is everything and x cannot equal 2, or something like that. But again, we're trying to write things more mathematically. And when it comes down to it, on an exam, well, usually I give paper exams, and I don't really care how you answer it as long as you're right. But when it comes to online homework and exams, you got to make sure to enter it in the way they expect. So that's why I'm going to be a little bit more careful than I usually am in showing you how to answer it in a lot of ways. If we were trying to use set builder notation, we'd start off with the same thing, the set of values x such that, and you could write it in the same way. X is an element of the reals, but x cannot be equal to -2. And a lot of the times the assumption is x is just part of the reals. So sometimes this might just be left off from the set notation, because that's just sort of a usual assumption when you're dealing with a lot of types of math. But in certain sets, you would be dealing with complex numbers or more other types of numbers besides the reals. But anyways, it's just, all the comma means is you're kind of saying this, but also this. We have two conditions as well. Or if we were going to use interval notation, this is how I would typically, most people would prefer writing it. If we're trying to imagine the set of numbers which work, again, I could draw a number line and shade in what numbers are part of it. Well, as we said, any number x works within this mathematical function, The only numbers that don't well, there's only one, which is -2. And so how we'd write that is, well, specifically at -2, we put an open circle for any value which is not part of our set, and then we'd shade in everything which is a part of it. So basically we have all numbers larger than -2 and all numbers smaller than -2, like 1, 0, -1. Those are all fine because they produce an answer. But numbers such as -3, -4, -5, those are not within the domain. Sorry, they are as well. The only one that's not is -2. But -3 works just fine. -4 works just fine as well. So all that being said, now to write the interval notation is always written from left to right, where left is -infinity and right is +infinity. Basically, I have the empty circle here breaks my shaded line into two distinct parts. The left part is from -infinity to -2. So basically how I'd write the interval notation is it's all numbers from -infinity to -2, or another way of reading this is all the numbers smaller than -2. But it's also all the numbers larger than -2, or to the right, from -2 to infinity. And it's both of those sets combined. And we use the union symbol which means or. It's a logical operation, or, which means I'm joining. It could be either in this set or in this set. And this would be the way that we'd write that complete domain using interval notation. And again, this would be the same exact meaning as set builder notation. In my mind, it's not. They're all legitimate. And if you are interested in studying math on a higher level, it's important to know like a lot of different notations because they're used in different contexts. But ultimately, for purposes of our class, I don't really care either way. But I'm trying to get you familiar with both methods so that you are good for the homework. Let's look at one last example and we'll wrap this video up. So, so kind of reverting back to what I was saying at the beginning of this example is that we're often looking for what values do not work. So looking at the next example, h of x is equal to the square root of x minus 3. With square roots, there are certain numbers that are not allowed, which is of course negative numbers. And if it's been a while since you've been in math or it's something you forget, remember that the square root of negative numbers have a bit of a problem. And remember, just to review the square root, I know this is pretty basic, but I don't want to leave anyone, behind. Remember, the square root is a mathematical function which determines what number squared makes this number. Exactly what it says, the square root. Well, technically this symbol is the radical symbol. Is not exactly the same as the square root. Don't get me started on that right now. But basically, in this case, it would be 2, right? Because 2 squared makes 4. Or, the square root of 9 would be 3, because 3 squared is 9. The problem with, what I could kind of think here is, well, what squared makes 9? Whoops. And that would give me the root of the square. But like one of the problems is, say I was looking at -4, I would be thinking to myself, what squared makes -4? To which, of course, it's impossible, because if you're squaring a number, whether it be positive or negative, any number squared is always positive. So it creates a mathematical impossibility. Well, technically, there are certain types of numbers that can square to be negative, but they're called non-real numbers or complex numbers, and we're actually going to review those a little bit later. A very, very interesting branch of mathematics, which seems silly, but has a ton of important applications in physics, in math, in a lot of different fields. Anyways, but when we're talking about domain, we're only talking about real numbers. So there is no real number which can square to make a negative, only non-real numbers. So this is an important distinction about domain, is what real values, because usually functions are defined to be real valued functions, where technically if you're in the complex plane, there are the domain would be different than when you're talking about real numbers. But for the purposes of calculus, algebra, college algebra, you know, more a lower level mathematics in the, you know, basic college level, we're usually just dealing with real functions. So we're only looking for the real valued numbers. So all of that summarizing, basically negatives are not allowed in there. Anything that produces a negative within the square root is not going to be part of the domain. So for example, if I was to plug in 0 here, h of 0 would be equal to square root of 0 minus 3. This would not work. And I can see that just by trying, because the square root of a negative is not real. Any non-real number is not going to be within the domain. It's kind of like in the World Series, it's something that's undefined. Well, technically it is defined, it's just not real. And we're usually looking for only real numbers. So, you know, anyways, but if I wanted to know, well, what is the domain? I would want to know, well, what, like another way I could think about it is the ones that will work are what make it positive. And the numbers that don't work are the ones that make it negative. But an easy way that I can do that is if I take the inside of the square root, what I could do is I could set it greater than or equal to 0, because 0 is the boundary line between positive and negative, right? Negatives are not allowed within a square root. Those are going to produce values which are not in the domain. So anything positive or 0, because the square root of 0 is fine, these are the values that will be part of the domain. So sort of, again, summarizing, if I'm trying to find the domain of a square root function such as this, I want to take the inside. I can set it greater than or equal to 0. These will be the valid numbers. And I could think about, well, what is invalid by doing that as well. But since I'm trying to identify the domain, I'm just going to focus on what works. Whereas over here, I was focused on what doesn't work because it was only one number, and you know, it can be a little bit different depending on what sort of mathematical entity is within the function. But again, I could solve that inequality by adding 3 to both sides. That would give me the set of numbers x is greater than or equal to 3. And then I could again translate that to set notation by writing it x is a set of numbers such that x is greater than or equal to 3. A very common way of this would be using the set builder notation, or if I was to use interval notation on a number line, I could start with 3, which would be to the right of 0, and to graph x is greater than or equal to 3, we'd shade to the right of 3 because it's all numbers larger than 3, but we'd also graph a solid circle on 3 because 3 is included. Whereas if it was just x is greater than 3, recall that we would draw an open circle instead because it's not included. Like over here, we drew the open circle because it wasn't part of it, but you always draw a closed circle like the shading to indicate that it's part of it. And then to write this using interval notation, it'd be all numbers from 3 going to infinity, and we always use a bracket on the edge of the interval when it's included. Like I was using parentheses here because it was not part of the set, but I use a bracket when it is a part of it. So specifically when you're dealing with certain types of functions, they will have brackets on their intervals, and certain other ones will have parentheses, and that's another confusing aspect. But again, it's all about, is it part of it or not at the end of the day? And again, however you want to answer it is cool, but just be aware of when it's asking for, you know, set builder versus interval notation. And that will wrap up this video.